start with Taylor series and the topics related to it. My screen is visible to you, right?
Yeah, it is. It is.
Okay. But before going ahead, we need to make a base for a few topics. Like one is binomial expansion.
Hmm.
Mm, let me stop annotation and do it using pen. Okay. One is binomial expansion and another one is differentiation, like calculus. Calculus has two parts, differentiation and integration. So we'll go with differentiation.
Hmm.
Now, I would like to know how much do you know about these two?
Binomial expansion, I have learned. Differentiation, I know.
Okay, you know that's.
Uh,
Let's go one by one. What is it? So, if I ask you what is an expression, what is. I asked you before as well, right?
yeah, equation
Okay.
and yeah, and an expression.
What is binomial expansion? I mean, what is what binomial expression? Bi means
Uh, Two.
so the expression having two terms. Now,
Hmm.
I can't say 1 plus 2 because these are like terms and these will result into one thing. So it is monomial only. For binomial, I need two different terms. Maybe 2x plus root 2, x plus 5,
Okay.
unlike terms. So, do you know a plus b whole square identity,
Yeah.
algebraic identity? What is it?
Mm-hmm. A square plus B square plus 2AB.
Now, it's pretty simple. I mean, we have crammed it. So that's fine as a part of rote learning. But how did we get it? So we did some of the activities also during school time and how using those small and big squares, right? Do you remember?
Yeah, yeah, it's been quite some time.
Yeah. But what if I'm asked a plus b raised to power 50 or plus b raised to power 1 by 4? Then this expansion is a savior. How it can help us is for that, we need to know about factorial. Do you know in permutation combination we used it?
Yes, yes, factorial, yes.
What is n factorial?
N factorial, if 2 factorial is 2 into 1, 3
Correct.
factorial is 3 into 2 into 1.
So what is happening? It is a series and we are for every successive element like multiplicand, we are having one lesser than the previous number, the predecessor. So
Hmm.
can I say n minus 1,
N
n
into n
minus
minus
2?
1 into n.
Wherever I
Yes,
want to
ma'am.
stop, I can, place this factorial there, right? That
Got
means
it.
it will be a series of this. So if I have to find out the binomial expansion of anything, for that, I need to have a binomial term, let's say x plus y,
Hmm.
and its power. So it is, you start with NCR, okay? You start with 0. You can say that wherever you want to stop, that R will always lesser than or equal to N, right?
Yeah.
So let's start with 0. NC0, if you take this first element, you can start with all of its power as whole, but you don't have y initially. Then you will keep decreasing x and increasing y.
Ma'am, I'm not able to, we did not get this step.
See, you have to take, this is binomial coefficient,
NC0.
NC0, NC1, NC2. So
Okay.
these are coefficients of these variables. You will start with x raised to power whole, and then you can decrease it n minus 1, then next will be x n minus 2.
It's 2 y raised to 2
Yes. And then next will be
n minus nc3 n my x raised to n minus 3 y raised to 3.
correct. What about yeah. So we are increasing value of y0, y1, y2, y cube, and so on. The last will be ncn x raised to power 0 and y raised to power n. Can you relate with it?
Minus 1 y raised to 1. Uh,
This will be
yes,
gone
got it.
completely, and this will be having highest power,
So that will
right?
be 1. And
Yeah.
that's going to be, okay.
So let's see how we can get x plus y whole square from this.
Minus 2 y 2 plus c n. Is this binomial expansion, ma'am? What we
Yes.
have done here?
Yes. But remember for that, for this expansion, n has to be a natural number starting from 1. For rational expansion, I cannot use it. Like for power 1 by 2, 3 by 4, that is a different formula. I'll tell you later. So this is the first formula for binomial expansion when n is a natural number. Because if it is 0,
Hmm.
then we know value will be 1. It is starting from 1 then. Okay. Is it fine?
Got it.
Okay.
Yeah.
Now it has to be x square plus 2xy plus y square. Let's see this formula is giving me this or not. So first value will be this one.
Uh,
What is n? If you compare it with this one,
n is 2 here.
2. So you'll start with 2c0 x raised to power 2 y raised to power 0. Then you will write 2c1 x raised to power 1 y raised to power 1. And then you will write 2c2 x raised to power 0 y raised to power 2, right?
Yeah. So 2c 0 x raised to power 0 y raised to power 2. Yes.
Now we only have come to know about the factorial, but there are two types when we have to do permutation and when we have to do
Hmm.
combination. Permutation
Hmm.
means arrangement. So if I have
Right.
my name, how do I want to? I mean, of course, name has to be written in a certain way, but if somebody wants to arrange these four letters and that too when two letters are repeating, so when whether I want to keep B at the first position or wherever, so this arrangement is permutation. And if I want to choose a character, choose an alphabet from it, that choice. Let's say I'm making a team of 5 people, three
So
girls,
the
two
order
boys.
matters here.
Yes. So that choice is combination.
It's
So what we
combination.
are
Got
having
it.
here, combination. Now the formula is
Hmm.
slightly different for both of them. When I have to arrange R elements out of n, I write it this way, and it is n factorial upon n minus R factorial. But when I have to
Got
do
it.
the choice thing, that is NCR, only thing which matters is R
You
factorial.
multiply that
Yes.
R factor.
I mean, because choices also have an arrangement, so we write R factorial for them. So that is basically
Hmm.
NPR upon R factorial, right?
Yeah.
So let's apply this formula here. So if it is 2C0, if I do it separately, that will be what? Using the formula?
So it's going to be 2 into 1 divided by
Yeah,
uh yeah, that's it. 2. The answer is 2.
correct. So basically we'll write 2 factorial upon 0 factorial upon 2 minus 0 factorial. This is the formula, right?
Yeah, the answer is 0 here. Yeah.
So 2 factorial, 0 factorial is 1 only.
0 factor. Oh yeah, 0 factor is 1. Yes, yes.
So this becomes 1.
Answer is 1.
So this has become
Right, 0
x
factor
square
is 1. Hmm.
Now tell me the value of 2C1.
So 2C1 is equal to 2 1 2.
Correct. So this has become 2xy and 2C2 is
2C2 is uh 0. No, no.
0 factorial is 1.
0 factorial is 1. Yeah.
So you have written 2 factorial upon 2 factorial into 0 factorial, right?
Yeah. Yes, yes. No,
So it,
but then, oh, yeah, that factorial into. Yes, yes, it's 1.
so this has become y square. Now, if you want to make this calculation quick, remember this fact. Are you stuck at this 2C2?
No, no.
Is this fine?
Yeah.
Hmm. So what is happening here? Can you see? I'll not do the calculation for NC0 and NCN because those will give me 1 only.
Hmm.
Okay. That means NCR is actually NCN minus R. This is also the generalization from this.
Yeah, NCR equals NCN minus R. Yes, that is true. 2C
Okay.
2. Yes.
Okay. So can you see x plus y whole square has become this, which we ideally learn?
Yeah.
Okay. Now, do you remember? Okay, have you jotted this down?
Got it. Yes, written.
Okay. Tell me x plus y whole cube, what is it?
So
Do you
x
remember?
plus y the whole cube, a cube. Yes.
Hmm.
A cube plus b cube,
Hmm.
3ab
Hmm.
plus 3ab
Into a plus
plus
b.
into a plus b.
So you can say this is the expanded form.
No, it is x cube plus y cube plus, oh yeah, yeah, 3ab. Yes, yes. So that's 3 x square y plus 3 y square x.
Is it fine?
Yeah.
Okay, now try it using binomial expansion.
So I'll do it. 3
Hmm.
c 0 into x raised to 3 to y raised to 0. That is going to give us 3c0 is equal to 1. 3c0 is 1. Therefore, 3c3 is also 1. Therefore, that gives us x cube plus three c1 is equal to 3. Therefore, this gives us 3x square y plus 3c2 also is equal to 3, which gives us 3 y square, 3xy square plus y cube. Yes, ma'am, done.
Great. So this is how you can calculate it for x plus y raised to power 100 also. You will simply
Yeah, but then
find out.
it becomes too long.
Yeah, you just do first three elements and last two elements and just epsilon in between. Okay.
Got it. Got it.
Now, what if n is a rational number in fraction? So for that, usually what do we do? Let's say if I have x plus y raised to power n, and this n is 1 by 2 or 3 by 4 or something like that, I do x raised to power n plus you multiply this with the power n x raised to power n minus 1 y n into n minus 1 upon 2 factorial. So see, this is whole x raised to power n. This is x raised to power n minus 1. Next will be x raised to power n minus 2. Here what is happening? 1 factorial. I mean, nothing is here. Here you have n. Here you
Yeah.
will be having n
And
minus 1 by 2 factorial. Then you will be having n
yes.
minus 1 into n minus 2 upon
And
3
minus
factorial.
2 the upon 3 factorial.
And then here you don't have y. This is y raised to power 1. Then you will be having y square and y cube. Is it fine?
And y cube. Just one second, ma'am. This to 2. Yeah.
So you started with x raised to power n and you finish at
Yeah.
y raised to power n. Okay?
Yeah.
So this is the slight change. So for instance, if I have to do x plus y or 1 plus x, let's say 3x plus y raised to power 1 by 2. Could you please try? Here n
Yeah.
is 1 by 2, x is 3x basically, and y is y.
Sample 3x plus y 1 by 2. This is gonna give us uh, was x raised to n. So x raised to 1 by 2 plus, just take, should I solve it or okay?
Yeah, you can, or you
That
can
is,
keep it as homework.
no, no, I'm solving it. I was just say asking, should I use the format that you just gave? I mean, it's the same.
Yeah,
It's literally the same.
usually for this fraction question, you will be given the expansion which starts from 1 because it is then easier. So it is 1 because 1 raised to power 1 by 2, 3 by 4, whatever it is, it will be 1 only. And then it will happen 1 by 2y. So you will multiply the power with it, right?
Yeah. Oh,
And
just one
then,
second. Someone is at the door. I'm sorry.
okay. So basically, okay. Got it.
Yeah, ma'am. I'm sorry.
Yeah, it's all right. Sorry, ma'am. So basically, whenever you are given an expansion for a
Hmm.
rational number, the question will give you that only expand it for first three terms because it is going to
Okay.
be very heavy. And also, they'll try to keep the first term as 1 because this
Got it.
also makes it easier because 1 raised to power 1 by 2 is 1 only. And then what happens? You simply multiply this power with the value, correct? So simply, I mean, you
Right.
apply formula and you can expand it, right? Just jot this down so that
Yeah.
you can try it.
Got it. How much should I expand this, ma'am?
Three terms.
Got it.
Okay.
So,
Now,
upon 2 x minus 3 upon 2 y square. Yeah, so root 3x plus 1 upon 2 root 3x y plus minus 1 by 4 upon 2 x raised to minus 3 upon 2 y square.
Didn't you get negative here?
Yeah, I did get negative, so I took that down.
Okay, that's right. So this is how you can do. I mean, you need to remember these two formulas. Sometimes you can find it in some of the entrance exams or somewhere. So remember this bit if you are asked to solve this. You can
Hmm.
remember at least two terms. So if I find out the approx answer for this, it will be 1 plus x by 2. You simply bring this power down, and this is 1 plus x by 2. Okay.
Okay.
Now, differentiation. So, what do you think? What is the understanding of yours as far as differentiation is concerned? Like the practical approach or something?
So differentiation is nothing but the slope of a particular curve. When you want to find a slope of the particular curve, you look at the value of the slope of the tangent at the point at the curve. So for that, for you to be able to find that, you differentiate the equation.
Yeah. So this is the mathematical thing. Slope is change in y. Slope is basically the gradient, the steepness,
Mhm.
and this is the change
Steepness.
in y over change in x. So that's
Got
fine.
it.
But if you want to find out the real life application of differentiation, is like, for example, I want to find out the area of a particular circle or circular shape or whatever. So I can divide it in infinite number of parts here, and if I take each of them and arrange here, let's say if I divide them further, like very very small parts, so and try to put them here as if they are some rectangular strips, and this distance is
Hmm.
very very small, change in x, and this is change in
Hmm.
y. So do you remember what we do? Like we want to differentiate, if we want to calculate the strip, the one strip, area of one strip, length into breadth, and we can have it n number of times. So differentiate means
Right.
dividing one thing into numerous parts so as to get into whatever you want to find out, be it number, area, you can put them and treat them as the strip of rectangle, and then can find out as if they are what? Dx by dt. Then you
dx
can
by dt. Yeah.
take them here, y dt equals dx. So length into breadth form will be formed. Now, if you have, okay, tell me, if you have x raised to power n, what's the differentiation?
So x into n raised to n minus 1.
Correct. If it is sin x,
Oh, we don't have trigonometry.
okay,
We did not have this.
okay. So basically, you don't have trigonometry from the scratch, or trigonometry in terms of differentiation.
No, 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 we
Okay,
don't have trigonometry.
okay. So basically, in like trigonometry means geometry of that is three sides figure. That is geometry of triangles is called trigonometry. And Aryabhat has
Hmm.
given us, we are basically talking about the right angle triangles only. So, initially at least. So what we have, you can consider any of the angles. Let's say I have considered angle C. So we consider
Hmm.
three things. One is opposite to 90 degrees, the longest side, which is called as hypotenuse.
Hypotenuse. Yeah.
Rest two are perpendicular and base. When we used to use
Hmm.
Pythagoras theorem, then we could consider any one of these two, perpendicular or base.
Right.
Basically, formalize hypotenuse square, perpendicular square plus base square. But when angle is given
Yeah.
to you, when angle is given to you, then it is very important that perpendicular can only be that thing which is opposite to the angle. So if I want to find out
Right.
with respect to angle C, my perpendicular will be AB, and with respect to A, my perpendicular will be BC. So this is
BC.
perpendicular, then rest, I mean, whatever is left, that is apart from AB, we have BC as base for this angle, and for
Yeah.
angle A, AB as base. You're getting it? Now
Yeah.
what happens? We have this acronym for what's
Yeah.
happening? For sine, cos, and tan ratios. So sine is
Okay.
perpendicular upon hypotenuse. Cos is base upon hypotenuse. And tan is perpendicular upon base.
Hmm.
We have total six trigonometric ratios. Opposite of sine is cosec. Opposite of
Okay.
cos is sec. Which board are you from?
CBSE. Yeah. I did. This is ninth and eighth grade.
Okay. So after 10th, what did you choose as your stream?
I had economic stats with math, but then even in my undergrad where I had calculus and all, we did not touch trigonometry.
Okay, okay, okay. So these are few things, the general idea that sometimes you will find
Mhm.
that this acronym, so we call it as Pandit Badri Prasad Har Har Bol. This is the Hindi acronym, I mean
Okay.
mnemonics through which you can learn it. And there is another also, SOHCAHTOA, wherein we don't call it as perpendicular base or hypotenuse at all. We call it opposite, adjacent, and so as I wrote here, what is it? We have, if this is the angle,
Hmm.
so perpendicular is what? Opposite to angle.
Is BC and base is your AB.
So I'll call sine as opposite upon hypotenuse, okay? I'll call
Oh,
cos cos as base upon hypotenuse. So bus base is what? This is angle, this is base, so it is adjacent, right?
huh.
So I'll call it as, I mean,
Yes.
I'll acknowledge it as adjacent upon hypotenuse. And when I'll find
Got
perpendicular
it.
upon base, I mean, this is the terminology for IB board. Those classy people, they use it. Like 10 is what?
Yeah.
Um, Perpendicular upon base, that is
Tan is your
opposite,
perpendicular by base.
yeah, opposite upon adjacent. Okay. So they call it so ka toa. This is their acronym. So ka toa. Okay. SOH, sine opposite upon hypotenuse.
Okay, ma'am,
Cos.
1 second. In this
Huh.
case,
Huh.
if the angle is A, my opposite divided by hypotenuse is, isn't that? Oh, no, no, no. Got it, got it. Got it.
Yeah, opposite,
Then
not
adjacent
opposite to
upon
90 degrees.
hypotenuse.
Opposite is not opposite
Got
to
it,
90
got it.
degrees. Hmm.
It's my perpendicular.
Yes. Now,
So adjacent and opposite of.
do you want to take its
So my
screenshot?
base,
Huh.
no, no, I'll remember it as perpendicular hypotenuse, base, hypotenuse, perpendicular base. That's
Okay,
much more easier.
right. So base is basically adjacent to angle, so that is fine. Now what we do, we have values also for sine cos 10.
Hmm.
We have so many values which we can do through calculator, but at least for these three and five values we should know. So I'm telling you a trick to remember the values. You simply make this table.
Did
The
my LSE portions have trigo, ma'am?
sine cos I have, I mean, if you've got this Taylor series, it has expansion of sine also. In your questions, I have not seen them, but I'm just telling you,
Yeah,
just for your information, we can drop questions
got
if
it.
you want, uh, but just so that you will
No,
not say that
no,
I have not seen this before. Yeah. Okay.
no,
So,
no, got it.
hmm, 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees, ये तुम्हें learn करना है. And then what you'll do,
ठीक है.
remember, write 0, 1, 2, 3, 4, divide them by 4
Hmm.
and take square root. That is the value. So tell me, what is sine 0?
So it's gonna be 0.
Sine 30?
Sine 30 is gonna be uh 1 upon 2,
Sine 45?
root 2 upon 2,
That is 1 by root 2. Sine 60?
1 by root 2.
Sine
Oh,
60?
ma'am, how is
Okay, so 2 ones are
uh
2, 2 twos are 4, right?
root 2 upon 2?
2 ones are
Oh,
2, 2 twos are
oh
4.
no,
Yeah,
no, 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 this is embarrassing. Sorry, sorry.
it's okay. It's okay.
Sorry. Oh
Sometimes it
no.
happens. Okay.
Yeah, root 3 upon 2
Yeah, and sine 90?
is 1.
Yeah, so always remember sine, values of sine lie between 0 and 1. I mean, 0 and 1 are inclusive. So from 0 to 1, okay? Now for cos, do the reverse.
Okay.
Start from this part. Sine cos 90 will be, I mean, cos 90, sine 90 is cos 0. So you'll start from here, then here.
Okay.
1 by root 2, 1 by 2, 0. Is it fine?
Okay. Hmm.
And then you have 10, which is actually sine upon cos. So tell me, what is sine upon cos for 0?
0,
Mm-hmm. 10, 30.
0, then it's going to be so once again root 3
2,
upon 4. No,
2 will
sorry.
be cancelled, no?
1 upon root 3.
Yes,
Yeah, 1 upon root 3. Then 1.
correct.
Then so root 3,
Yes.
0.
0 नहीं? 1 by 0. That is not defined.
Oh, one not defined. Infinity.
Yeah. So if you remember these, then cosec is inversely proportional to sine. So cosec 0 will be 1 by 0,
Yeah,
cosec 30 will be 2, cosec 45 will be root 2. Similarly, tan is opposite to cot. So cot 0 is 1 by 0, that is not defined. Cot 30 is root 3. Is this fine?
got it. Yes.
Great. Now, I was telling you about the formulas for sine and cos. So just remember at least sine and cos one. So differentiation of sine is cos, and for cos it is minus sine. Okay.
Okay.
Now, tell me if I have displacement as a t function, 2t square minus 3t plus 4, what will be the velocity at t equals to?
So velocity t equals to what it? T equals to the velocity would be second 5.
Okay. So velocity is displacement upon time. So that means I'll do dy by dt first. So 4t minus 3,
Hmm.
and then v at t is 2 is 4 to the 8 minus 3, 5 units, whatever it is. Good. So this is how we do
Yeah.
displacement. Now, do you remember product rule?
Yeah.
What is it?
The UV rule.
Whenever you have products, you keep, I mean, you do, whenever you have product, you do differentiation of first one, keep second one as it is, and
Plus
then, yeah,
V differentiation. Yeah.
correct.
I
So
can
let's
I
say,
can do optimization and partial differentiation tak I can do, ma'am.
oh, that's great. That is,
Concavity, convexity also I know.
that's good. So you have gone through it or you did it earlier?
I just did it last month. I did finish differentiation. I can
Ach-
do up till partial differentiation.
Acha, okay. So only one class we are contributing to basics for that, and then we'll start Taylor series, okay?
Okay, ma'am.
So if I have to do differentiation of x sin x, what I'll do? Or x square sin x, let's say.
Oh, so it's going to be 2x
Hmm.
into sin x
Yeah,
plus x square into cos x
perfect.
divided by.
No,
Oh no,
there
no,
is
there's
no
not
division.
quotient rule. Sorry. Yeah.
Tell me what is
I,
quotient rule?
quotient rule the same UV rule. मगर numerator में it's going to be minus and denominator is going to be v square denominator square.
Yeah, denominator square. We keep denominator first because in negative sign, order matters, right?
Okay, yeah.
So this is how we do it. Tell me, if it is this square root of x, 8 cube root of x minus 2 fourth root of x. Tell me dy by dx.
So the dy by dx would be 1 upon 2 x raised to minus 1 upon 2
Yeah.
plus 8 into 3 root x cube root of x.
3.
No, no,
We
8 into, sorry, 8 into 3, 8 into 1 upon 3,
Mhm.
x raised to 1 minus 2 upon 3, 2 upon 4,
Mhm.
x raised to minus 3 upon 4.
Right. Now, what is chain rule?
So that's dy by dx equals yeah, chain rule is when you have to I can solve chain rule.
Okay.
It's dy by
Base.
dx is equal to dy by dt into dt by dx.
Correct. So you have function within function. Need to suppose
Hmm.
it for something and then do it. Tell me what will what it will be. So firstly, we'll do sine x. Sine x is what? Cos x.
So it's sin x, yeah, sin x is cos x
And
into
now, yeah,
into 1 upon 2 x raised to.
correct. Okay, so you got it. Now, do you know about increasing and decreasing function? Because that will be required in optimization. How can we check using differentiation whether a particular function is increasing or decreasing? Hello, Purjit, am I audible? Increasing and decreasing function we have been talking about.
Hmm.
If I tell you that this is the function, tell
Hmm.
me whether it will be increasing or decreasing. How would you do that?
This is an increasing function.
Okay, how?
When the a is positive, the a is positive, it is an increasing function, right?
Okay, so that goes for the
If I'm
vertex form of parabola, but
okay.
we are talking about this. And for this, we need to do either first order derivative
Oh, my
test.
bad, my bad. Sorry, this is off. Yes, yes. We do the first order derivative, and if the first order derivative, we then equate it with zero. When we do that, when we equate the first order derivative with zero, the value of your x. No, 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 no. You solve for x, and then you know if the function is increasing or decreasing
Yeah, you put the
after
value
first
and
order
then you
derivative.
correct. So let's find out. Tell me the derivative.
The derivative is 14 to 3, 120 x square minus 20 x cube minus 20 x raised to 4.
Okay, now tell me, I need to find out critical points for it.
Yes, now critical points where x is neither increasing or decreasing at that point.
So I need to firstly simplify it. With which number can I divide it?
We could initially take x square common, 20 x square common. So it'll be 6 x square, no, sorry, x square.
X square is out, no?
We could do minus 20 x square.
Okay.
So that would be minus 6 plus x plus x plus x square.
Tell me its factors.
So the factors would be 3 and 2. So minus 3 plus 3 and minus 2. So x square plus 3x minus 2x minus 6. Then x plus 3, x plus 2 minus. So yeah, it is x minus 2 and x plus 3. So x is equal to either 2 or x is equal to minus 3 or x equals 0. Oh yeah, yeah, x equals. Hmm.
Okay. So once you get these critical points, what you are supposed to do, you need to find out the value for which this uh, do double derivative.
Yeah. F double dash x is equal to so 120 था ना, so 240x minus 60x square minus 80x cube. Hmm.
So there are two
So we
things.
substitute each of these critical values.
There are two things. One method is you can put these values and find out what is the value of f dash when you are putting. If it is negative, it is decreasing. If it is positive, it is increasing. Or you can find out this double derivative, put down all those values, the critical points,
Hmm.
and check whether it is negative or positive. So if it is negative, again, minimum, maxima you find out, and then you
Hmm.
draw a number
So
line to
it could
find
be the
out the
relative
intervals.
minima, relative maxima,
Correct?
and yeah, and then it would be then, ma'am, we could also find the concavity convexity, right? If
Yeah,
it's
correct.
positive, it's relative minimum plus convex, negative relative maximum plus concave.
Correct. Perfect. And then you can find out the intervals also. Like here you have -3, 0, and 2. So you can have, this is minus infinity to infinity. So you can have intervals, and in those intervals you can say whether it is increasing in this interval or not. Okay?
Hmm.
Right. So you need to solve it. Just jot down the idea and you need to tell me the answer later on.
मैम, इंटरवल मुझे समझ नहीं आया, हाउ?
अच्छा, मान लो इफ आई एम पुटिंग हियर एनी, ठीक है, मैंने क्रिटिकल पॉइंट्स निकाले ऑल दीज थ्री.
हाँ.
So I have divided into interval the values of x from minus infinity to minus 3. Consider any of the point from minus infinity to minus 3. Let's
Hmm.
say -4, and substitute
हाँ.
here. So
ओके.
6, 40, and check whether it is coming out as negative or positive. Once you find that out, if it is negative,
Hmm.
that means it is decreasing.
ओ, समझ गया.
Hmm.
मैम,
And then
मुझे
let's,
आई हैव अ
uh,
डाउट.
huh,
I know why we do this concavity, convexity.
huh.
What is it? But then, could you graphically explain what is happening in first derivative and why are we going ahead with second derivative?
Sure, we are heading towards it. Just bear with me. We'll come to that.
Okay, cool, cool.
I'll explain you, na?
Sure, ma'am.
So,
Sure.
this is just increasing and decreasing. Now, coming to Taylor series expansion. Do you have anything to jot down till here?
No.
Okay. What do you know about Taylor series?
Uh, yeah, I remember doing Taylor series. I did solve it last month. That's that is closely related to implicit differentiation.
Okay, basically, you know, Taylor. has derived it in order to find out infinite sum of terms. You'll find out that
Finite
every particular term is getting
of
larger and larger. For example, if you have non-terminating, non-repeating terms, let's say, and if you want to find out their values, what will be the exact, let's say up to 5 decimal places? If we constrain that, that is fine. But what will be if we keep on increasing the number of terms? It will get more precise, right? No?
uh
Okay, I'm giving you an example. I will tell you the derivation also, but just look at this. This is exponential expansion. If I expand it using Taylor series formula, it is 1 plus x square by 2 factorial, x cube by 3 factorial, x raised to power 4 factorial, and so on.
hmm.
If I ask you, put x2 and find the value. Do you have calculator with you?
uh
Mobile
yeah,
will
I
work.
have my phone calculator.
Yeah, that's fine.
Yes.
Just type E on calculator and get me the value.
Okay. Just 1 second. Calculator. Calculator E exponent of
Just E. What is its value? E and
2.
press enter.
2.718
So
E का value.
2.718 and so on raised to power 2 here. And then if you do it,
Hmm.
again you will get some value. But it will, it will be having infinite number of terms, right? And how can I get
Right. Because, ma'am,
the,
is it because
uh,
is
uh,
it non-terminating?
yes, non-terminating. It is not getting stopped. Also, it is not repeating. Otherwise,
Okay.
I could have done it 0.34 bar because these two
Right.
terms, yeah. Now, this is the calculator thing which we have done. Now, if I want to
Hmm.
elaborate, expand it using this Taylor series, it will be like I'm putting here value of x as 2. Now, see, if I consider only first two values, what it will be, e raised to power 2 will be 1
So
plus 2, that
3.
is 3. Not bad because e is 2.71 and by rounding of
Hmm.
tools, it can be 3, but that is an approximation. Then, if I
Yeah.
take another value, I mean term, first 3, what will be the answer?
So that would be 2 4 by 2. So it's 2
2 to 4 and 5.
5. Yeah.
Then, it is e square. What is happening? If you do the square of 2.7182, what it is?
2.718 is equivalent to, just 1 second, 2.7 2.718, the 7.3875.
Okay. So you can see this is not even close.
Yeah.
Then let me take the value
Oh,
1
this is,
plus,
oh, not sorry, this I meant to say linear approximation.
yeah.
close to linear approximation.
But it is happening
But this is not
exponential
linear.
way. Yeah, it is as
It is
happening
happening
exponential.
exponentially. Got it,
So
ma'am.
2 cube by 3 factorial. If I do so, 8 by 3. 8 by 3 is something. 3 to the 6.
It's equivalent to
20 something.
two 2 point, yeah. So, ma'am, it would be 5 plus 2.66, no?
Uh, Correct. So
So
7.66.
this is
Now did you see
7.66.
it is getting closer?
Mm-hmm.
So what I'm
Yeah.
trying to say, even if I mean if you go with higher terms, it is
Mm-hmm.
giving you this Taylor series expansion is giving you infinite sum of terms to get more precise value of something. And that something is non-terminating, non-repeating value.
Got it. Ma'am, and also ma'am, over there when we did 8 by 3, were supposed to do 8 by 3 into 2 also, right?
No, I did 2 cube. This is only x
Yeah,
cube
that is
by 3
8
factorial.
divided by 3 into 2, right?
Correct.
So I mean,
Correct.
this would bring us approximation to closer to
Yeah.
3.7.3.
More closer value. Okay. So it will be
Got it.
3 to
Got it.
the 6. So 2 4 is 8. 5 plus 3 ones are 3. 3 3 6.33.
2.1.33.
Correct.
Summary.
So you
Yeah.
can see what is happening. Infinite sum of the more we get, I mean, if we consider more number of values here in expansion form, then the closer answer we'll get. Okay. So that's how this Taylor series
Hmm.
expansion works. And if you want to generalize it, see what is it if I want to. This is the summation of what? Of this general form, right?
Yeah.
What is that which you are putting as an initial value of n?
Initial value of n
Here,
is x factorial.
no, first term is 1. How can I get 1? What should I put in place of n?
Oh, 0.
0 to infinity it will go. Okay. So this is how we write the general expansion. Now let me tell you how come this formula we got. We got this using, shall we move ahead?
Yeah, I'm written it down.
Okay, now let's say you have any, this is exponential, it can be 10x, it can be sine x, it can be x square plus 3x, any function. So let's say this fx, actually as per this Taylor series, it is what? Do you remember the formula? Initial value, like,
Yeah.
huh,
Yeah.
and first
X.
derivative,
Yeah, plus f of first derivative of a, x minus a, plus f second derivative of a divided by 2 factorial into x minus a square. Yes.
so we can write it in general form as, here we have nth order derivative of fa divided by n factorial for x minus a raised to n, right?
Yeah.
Now see how we got this. Let's try with this general form of any a and x raised to y n, where you have coefficient, and this is generally what we call as polynomial algebraic expression, a1x, a2x square, right? This is the polynomial
What is
expansion,
it called as, ma'am?
polynomial algebraic expression.
Oh, okay, right. Got it.
Now, if you are elaborating it, so you are
Hmm.
getting a naught x raised to power 0, a1 x raised to power 1, a2 x raised to power 2, and so on up to infinity. When you put x as 0, what will be your fx?
1.
Whole fx.
Oh, the whole fx when you put x as 0. Oh,
Yeah.
that would be 0, ma'am.
Check again. You are only putting x as 0. So this is 0, this is 0. But what about this term?
Oh, x is to 0, 1.
So this coefficient is left, right?
1. And a 0. Yes.
Now let's do the differentiation on differentiating with respect to x. What is happening? This is
F
constant.
dash x equals, yeah, 0.
Then for this expansion fx, tell me the f dash x for
Oh,
this.
that, okay, okay. For that, it is, uh, yeah, for that, that would be x, no, a1, x1, a1
x1
x raised to
is,
1.
no, x raised to power 1. Derivative of x raised to power 1 is what?
Oh, right, right. Sorry. A1 plus
Uh,
2 a2x
Correct.
plus, yeah, 3 a3x square.
Right. Now, if I ask you again, if you put x as 0 here,
Hmm.
what will happen to
A1.
f? Now, if you again differentiate, firstly f double dash x. This is your f dash x. Tell me the differentiation of this.
F double dash x.
Yes.
Uh, that would be 2a2 plus 6 a3x.
And so on. What will be f double dash 0?
0 would be 2a2.
Right. So, can you see if I generalize it? Like, if you take this 2 in denominator form, it is a2. Yeah.
F double dash.
2 in denominator.
Yeah.
So, I
Yes.
can write it as 2 factorial.
Yeah.
So, can I say if it is 2, then I'm having double derivative. I'm having 2 factorial. Can I generalize it? If it is 2,
As
it is
just
double
a2.
factorial. Yeah. So, if it is n, then it has to be n factorial in an. right?
Yeah.
So this is one form. So here f raised to power n is not raised to power. This is what? Derivative, nth order derivative, right? Did you get it? No?
Oh, yes, yes. Nth order derivative. We got it, got it.
Okay,
Ma'am, I'll just note this down. The-
sure, sure.
Yes, ma'am.
Now, if I substitute this value, all these values which I've got here in fx, this is my power series. Tell me what it will be. Here I'm writing fx is equal to, this is 1, this is actually a naught x raised to power naught. So that is basically a naught only, right? This is a naught, right?
Uh,
X raised to power 0 is 1. This is a naught only, right?
yeah, yeah.
So what is a
Yes,
naught which
yes.
we got?
So your f of 0, the
Then we have a1. What is a1?
A1 is your f dash 0.
And here is x. Plus, what is a2?
A2 is my f dash 0 divided by 2 factorial.
F double dash 0, right?
Yes, f double dash 0, sorry, divided by 2 factorial.
And this x square. So can you relate with this formula? What is happening?
Hmm. Yes.
Right, firstly the constant value, then single derivative x, then double derivative by 2 factorial x square, and so on.
Yes.
Done?
Yes.
Now, if I make it in more generalized form, just like we have x1, x2, where is it? Yeah. How can I write it in another form? If I consider x as a, I'm trying to write it in this form, this one. Okay. I'm trying to make it in this form. So
Hmm.
in uh, at the moment it is 0. What if it is some other value, right? So for that, what I'm doing, let's say x is a, and here fx is which form? This is constant b. This
Yeah.
is the derivative of b. right? And you can displace this as x minus a, and then p2x minus a whole square, p3x minus a whole cube. What is happening here? So I have considered
Ma'am,
this
I
p.
don't get it. I didn't get this part.
Okay. So what I'm doing here, this f raised to power n by n factorial, this one, I'm considering it as b.
Okay.
Is it,
Okay.
is it fine?
Ma'am. Yes, now let us consider. Got it.
If I substitute here n as 0, so my answer will be
Hmm.
b, then b1 x minus a. What I'm trying to do is to establish that relation. Now you can simply substitute it.
Ma'am,
I
why
mean, if you
x
don't,
minus a?
so x minus a, what we are doing, it is the basic difference. B is the difference between the intervals.
Hmm. Oh, what is the interval difference between
Not
interval
getting it.
here?
Okay. Let us try some. Have you jotted it down?
Yes, up to I've brought it everything now.
Okay. So what we are doing here, we are just elaborating if it is F0. See, in this, when we have put exact A value as 0, right? A,
Huh.
we have here A as 0, right?
Yeah.
So here what I'm trying to do, I want to have this X as A. So A minus A is 0, A minus A is 0. Every single time I'll get F dash 0 only, F double dash 0 only, right?
Yeah, in this case when x is equal to a.
Yes. It is this form only when here A is 0, X is equal to A is 0. It can be any other thing. It can be A as 3, 4, 5. Then I would have substituted it in this manner. Is this fine?
Got it. Oh, again, it's nothing but the same format.
Same,
Here also it's
same.
b1 0 raised to 2, b1 b3 0 raised to 3.
Yeah. Why
It's
I'm
the same
telling you
format.
these many formats, because in your proposed syllabus, which you sent me, during the first interaction to demo one,
Yeah,
it is given in the very elaborated form and various formulas have been used. So just trying to tell you that this is nothing but that formula only. Fine?
got it. Got it.
Great. So if you want to write it in B form, then also it's fine. Or else you can just simply come back to that which we talked about. Okay? Instead of 0, 1, 2, 3, whatever, this can be the case, right?
Hmm.
Now, if you've got it, solve this question. This is the function, and here the expansion from which you have to start is minus 3. Find the expansion for this function.
Okay.
First of all, what are you finding?
I found f0 is 0.
Okay.
And then I found f dash x,
What is f dash
which is
x?
x minus 4x.
X minus 4x.
Yeah.
Differentiation of this. 2x is?
Oh, no, 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 no. Sorry, sorry, sorry.
Yeah,
Yes, 2 minus 4x.
correct. And then double
Then f
derivative
dash 0. Then, okay, got it. F double derivative x equals minus 4.
and triple one.
Triple derivative is 0.
So I don't need to find out other higher derivatives. It's done. Now
Hmm.
what I'll do, my because only three elements are there, so n is 3, a is minus 3, it is
Hmm.
starting from a. So I'll just expand it using Taylor expansion. What it is,
Hmm.
initially it is fa, then f dash a x minus a plus f double dash upon 2 factorial x minus a whole square, right?
Yeah.
And then triple dash minus 3. Did you get it? I mean, are you getting it? What is happening?
Uh, I get I get what we are doing here. Since we have assumed that x equals a, we're substituting the values of a. Nahi.
It is simply the formula.
Yeah, that I understood, ma'am. It's we are
Huh.
substituting wherever we have written a in the formula.
Yeah. So, is this the question that why we are taking a as minus 3? What is
Yeah.
that? Which okay. So basically, question is, when we want to find out whether it is maxima and minima at this point, so this point is given to us that you need to
Okay.
expand your series around this number for this number. Okay.
Got it.
So that's why I'm substituting a as minus 3 up to 3 terms. I'm going to keep x as it is so that whenever it is asked that find out whether x is equals to 3 or x is equals to 13, which one is minimum. So I can simply put down the value and find it out. Okay.